So today our topic is called kinetics of particles. So previously we have been learning about kinematics. So previously we learned something called kinematics. This we have done this one. But this one is for particles. Currently we are learning something called kinetics. Also for particles. So we are now under mechanics of rigid bodies, statics done. Currently we're doing dynamics. Last week we were doing kinematics. Currently we're doing this one, kinetics. So as a refresher, kinematics you only consider on motion. Motion, no force. So for kinetics you consider motion and force. So two things. So under kinetics, you will be learning back all the Newton's three laws of motion. So you have your first law of motion, which is if you have a particle which is originally at rest or moving with a constant velocity, it will remain in this state provided that the particle is not subjected to any unbalanced force. So second law, if a particle acted upon an unbalanced force, it experiences an acceleration that has the same direction as the force and a magnitude that is directly proportional to the force. So for the first law, it's a lot on equilibrium, static equilibrium. On the second law, this is what we are learning right now under dynamics, kinetics. Finally, third law, it will be forces and action and reaction between two particles are equal, opposite and collinear. So for this chapter, we'll be learning kinetics and we'll be using a lot of Newton's second law, which is summation of forces is equal to mass times acceleration. So force is a vector, acceleration is a vector. Mass is not a vector. Okay, so for equation of motion, we'll be learning this one lah. Summation of forces is equivalent to mass times acceleration. So since we have three axes, you need to consider all the axes. Axis X, axis Y, axis Z. So by right, you need to settle summation fx equals max, summation fy equals may, and finally summation fz equals maz. So if the object in motion satisfies certain kinematics constraints, for example, if the object in motion, the acceleration is constant. So if you still remember, there are three formulas from last week that we can use if the object is under constant acceleration. So this formula is valid, second formula is also valid, third formula is also valid, and you can use it. And if you have normal or tangential coordinates, you can use this one. Summation f normal is equal to m normal. Summation f tangential is equal to m tangential. If you still remember, if an object moves through a curved body, we are going to get a few components. Number one, A tangential. Number two, A normal. This is your A. So A normal is equal to V squared over R. So this is what we learned last week. So next, yeah, pretty much. So there are a few formulas that we can apply, for example, in kinetics. So let's do an example. Once we do examples, we can really understand what we are talking about. So let's say we have a box. This box is on the floor. It weighs 50 kilogram. So this is the box. The coefficient of kinetic friction is now 0.3. So previously you have coefficient of static friction, right? Now for objects which is in motion, you'll be using something called mu k, which is kinetic friction. So this is the object lah. The load being applied is a 400 Newton towing force. So the things that we need to find is find the velocity after 3 seconds starting from rest. So how do we do that? So number one, definitely you need to draw a proper free body diagram. So this is our box. This box, it weighs 50 kilogram. So it's on the floor. It has normal reaction force. It is being towed like that by 400 Newton. So the angle of the towing is like so, and the angle is 30 degrees. And also this object is, yeah, it's on the floor. It's on a flat surface, and this flat surface has a coefficient of kinetic friction of 0.3. So from our previous understanding, when you have friction, so this is the direction of motion. So you will have a resistance due to friction. So this one is called FKY because mu k times normal. Fk stands for kinetic friction. So you're using mu k, which is kinetic friction coefficient. So this is the whole free body diagram. So in order to solve this, you need to call out your second Newton law, which is summation of forces is equal to ma. So currently, this box is on the x-axis, so you will be analyzing summation fx is equal to max. So let's settle it. So the direction of motion is considered positive. So since this box is traveling to the right hand side, so right hand side is considered positive. If your box is going to the left, left is a positive. If your box is traveling up, up is positive. If your box is traveling down, down is positive. So for dynamics, we'll be using this convention. The direction of motion is the positive. If your box is traveling this way, so this way is positive. If your box is traveling this way is positive. So you get the point, right? So in dynamics, the convention of motion depends on the direction of the motion. The convention of positives and negatives depends on the direction of motion. So it's not like static, whereas everything to the right is always positive. So that's not the story already. In dynamics, you follow your motion. Kotak ni gerak kanan, so kanan positif. Nanti kalau kotak tu gerak kiri, kiri is positive, okay? So, yeah, so let's do it. I'm gonna shorten this thing. This is normal. So, summation fx, the total forces in the x direction. So this one can be rubbed off. I'm gonna rub this off. Yeah, so you just have to look at your free body diagram. You don't have to worry about any other things. Look at your free body diagram. Summation of forces. Kanan is positive, so everybody has got this convention correctly. To the right is positive. So you have 400 cos 30 degrees. Okay, minus mu k times normal. And that's it. Equals MA, habis. A bukan sebarang A, MAX. So 400 cos 30, berapa dapat jawapan? 400 cos 30 degrees. 346 minus mu k 0.3 kali dengan normal. Normal tak tahu Normal tak tahu, just leave it there first. Mass. So this is mass. M. So definitely key in 50. Acceleration. So mass ni nak kali dengan 9.81 tak? This one. Kena tak kali dengan 9.81? Tak payah. No need. Mass is mass. No need to multiply by 9.81. Mass, the unit is kilogram. So just put in 50 kilogram. No need to multiply by gravitational, no need. So you are trying to find the acceleration in the x-axis. So you got this equation lah. So this equation you can simplify it a bit. So you're gonna get like 50 ax plus 0.3 normal is equivalent to 346. So this is what you get for summation fx. So obviously you don't know normal. What is normal? Alright, so we need to find out what is normal. We don't have normal value. So in order to solve normal, we need to solve summation fy is equal to may. So, the good thing is, you know that this box is not going to travel up. It's not going to fly, basically. So definitely this box is just traveling this way. It's not going to up in the y direction. So you know already, ay is definitely is equal to 0. Why? Because there is no motion going up. So this one becomes 0. So luckily your equation become summation fy equals 0. So now you just have to analyze all the forces in the y direction. So you've got normal going up minus mg going down, and you have this 400 component. 400 is going up, so it's a positive. Mg sine 30 degrees equals 0. Okay, normal going up, mg going down, so 400 is going up. No, it's not mg, right? It's actually 400 sine 30. 400 sine 30. Okay, so normal equals mg minus 400 sine 30. mg berapa? 50 kilo. 50 by 9.81 minus 400 sine 30. 200, right? So 50 by 9.81. So 490.5 minus 200. So you get 290.5 Newton. So one thing that you notice here, this box this box is actually being pulled in that direction. So you have 400 in two components lah. You have one component X, one component Y. So by right, the normal dekat bawah ni, it becomes lighter because you are pulling it like that, right? This 400, you have components. One is like this, the other one is like that. So this is the 400 cos 30 degrees. This is the 400 sine 30 degrees. Due to this box is being pushed upwards, kita punya normal pun kurang sikit. So frictional forces pun jadi kurang lah. So let's plug in. So by plugging in this normal inside this equation, so let's plug it in. So 50 AX plus 0.3 290.5 equals 346. So what now? AX sama dengan 346 minus 0.3 kali 290.5 divide by 50. So you get 5.18 meter per second squared. So this is the box acceleration, 5.18 meter per second squared. So kalau nak cari velocity in 3 seconds, what do? You need to use kinematics equation. Kinematics equation ada 3. 1, 2, 3. So this 3 equation is used for constant acceleration. Remember, it can be used for constant acceleration. Constant acceleration. So our acceleration is going that way. Okay, going this way, AX, and the acceleration is constant. Why is it constant? because the 400 Newton is constant. F is equal to MA. Ini equation dia kan. Mass berubah tak? 50 kilo. No change. Constant. Dia bukan ada macam dia bawa pasir, kotak ni bocor. Terkeluar pasir, keluar pasir. 50 kilo lama-lama kurang. Then different story lah. Ataupun dia bawa air tu kurang. Then different story. Mass dia berubah dengan time. For example, you have a rocket, right? The rocket, it carries a fuel. As it burns fuel, it becomes lighter and lighter. Aircraft also the same. Aircraft bawa petrol kan, kerosene untuk dia terbang. As it travels further and further, it becomes lighter and lighter. So that is different story. So this box weighs 50 kilo. Dah habis pun 50 kilo juga. Constant. So acceleration, adakah acceleration constant? Force pula tengok. Force 400 Newton. 400 Newton constant. Kalau tak constant jadi macam mana? 400 T squared. Ini tak constant lah. Dia berubah dengan time. 400 T ke? 1 second 400 Newton. Second jadi 800 Newton. Different story already. So in this case, it's 400 Newton. Constant. So everything is constant. Acceleration also constant. So acceleration is constant. So we can use this equation lah. Cari velocity after 3 seconds. So senang je lah. Use the first equation. V is equal to V0 plus AT. V0, original velocity 0, acceleration 5.18, time 3 second. Berapa jawapan? 5.18 kali 3, 15.54 meter per second. This is the answer lah. Alright. Alright, so next question. So previously, we see something like this. This box is being pulled like that. 400 Newton. So the good thing when you pull something like this is you are pulling it like that and you are lifting. This is pull, right? Pull. This is lift. So when you pull and lift, your mg is like this. Your normal is reduced. What do I mean by that? When your normal is reduced, sebab dia angkat, lift. When your normal is reduced, your frictional forces is also reduced. Your mu k kali dengan normal. This is your friction, right? Which is equivalent to Fk. So you're doing an action called pull and lift. However, if, for example, you are doing a process like this, so your 400 Newton is like that. So you are no longer doing the pull and lift. You are actually doing a push. So push and pull sama adalah it's forward punya force. But you are doing this press or something called tonyo. So you are pressing to the floor. So when you press to the floor, your normal is no longer reduced. It is increased. So you press, so your normal is increased. So once your normal is increased, your mu k also will be increased lah. Your kinetic friction, which is equivalent to mu k kali normal, will become harder. So your box is harder to move. We have lost a lot of good forces by doing this action lah, by doing this pressing action and tonyo action. So these examples might be simple. All these things might happen in your real engineering activities. So you should be able to make proper decisions in order to increase the efficiency of your work. So these are the basic principles. It's bad if you're trying to move something up, you might as well reduce the frictional forces. Okay, so now let's look at next problem. So, as what we have been telling you just now, this is a bad idea. This guy is pushing forward, but he is also creating the... he's trying to push, but also he is at the same time pressing down. Okay, so you get the point. So now let's read the rest of the story. 80 kilogram block rests on a horizontal plane. Find the magnitude of force P required to give an acceleration of 2.5 meter per second to the right hand side. A sama dengan 2.5. Kinetic friction coefficient is 0.25. Okay. Not so bad. Right. So when you do the free body diagram, label the forces involved. Mg, normal, frictional forces, mu k kali dengan normal. This is P lah. So when we are talking about P, you know lah this action this action and this action. This will be, this is 30 so this will be 60. Okay, so this is 30, this is, no lah, right? This is 30 also, right? 30 lah, like that. If this is 30, this is also 30. Right? This one is 60. Betul lah. That's correct. So if this one is 30, this is also 30 degrees. Yeah, correct. So this will be P sine 30 degrees. This will be P cos 30 degrees. Alright, so now let's do. Summation of forces in the x direction is equal to MAX. So coincidentally, dia nak pergi kanan. So kanan lah positif. So label all the forces. Now let's do it. P cos 30 degrees. Apa lagi minus mu k times normal. I think that's it. MAX. P you don't know. 0.866 P minus mu k 0.25 normal kali dengan mass. Mass again, letak 80 je. Tak payah nak letak 9.81. Yeah, 2.5 is the acceleration. So you get the equation lah. 80 times 2.5, 80 times 2.5, 200. This is equivalent to 200. Let's not waste the space here. So summation Fy is equal to 0. Summation Fy is equal to 0. Normal tolak mg minus p sine 30 degrees. Anything else? It's not equal to 0, right? It's equal to something called MAY. And it happens to be that AY is equal to 0. Then it becomes 0 lah. So n minus mg minus p sine 30 equals 0. Anything else am I missing? Ini dah. What else did I not do? This one done. This one already taken into consideration. Done. This one also done. This one also done. So all the forces labeled in your free body diagram should be taken into consideration. So normal tak tahu. mg 80 kali 981 minus 0.5 p is equal to 0. So you might as well arrange it properly. So when you bring everything to the right hand side, 0.5 p minus n, correct ah? 0.5 p bawa sana. Oh, might as well don't ah. Minus 0.5 p plus n is equal to 80 kali 9.81 784.8 784.8 plus n is equal to this. Yeah, okay. So this is the equation lah. This is the equation which you should solve simultaneously. That should be solved simultaneously. So use your calculator lah. Use your calculator. This is A, this is B, this is C. This one is equal. This one. Yeah, you gotta put in everything lah. A berapa? So arrange properly. P depan, P depan. 0.866 B minus 0.25 C 200 minus 0.5 1784.8. So dapatlah jawapan The first one will be X, second one will be Y, and berapa? So punch in your calculator. 51.866 minus 0.25, 200 minus 0.5, 1784.8. You're going to get a value of This is the answer. 534.7 Newton. Okay. 1052 Newton. Apa soalan dia? Coefficient of friction. Find the magnitude P. Apparently P is equal to 534.7 Newton. Is this correct? Kat mana jawapan dia? P is equal to 535 Newton. Normal dia tak cari pun 534.7. So okay lah. Okay, so this is done. Alright, so that is next exercise. Okay, one more. Take a break if you want to. Pause the video. And when you're okay to go, continue. Right? What? I'll continue. Okay, so this is a casting. Casting. What is a casting? Anybody know? Casting. It's not acting, it's actually what is it? There is something called die cast and there is sand casting. It's probably sand casting, this one. Casting. Sand casting. Some sort of like acuan. So this is done for a very heavy stuff. Sand casting. This has a weight of 3 megagram. So M besar, G kecil stands for mega. Megagram. So 3 times 10 to the power of 6 gram, or 3000 kilogram, or 3 ton, 3 ton. So this weighs 3000 kg in our SI unit. Suspended in a vertical position, initially at rest. So when time is equal to 0, initially at rest, velocity 0 lah, displacement also 0. It is given an upward speed of 200 mm per second in 0.3 second. So originally at rest, kita jerk, becomes like this, So kind of like we give it an acceleration lah. We kind of jerk it due to this motion. This is a hook. So jerking action produces more forces. Why? Because of this lah. Force is equal to MA. Kalau A kamu tinggi, which happens during the jerking motion, kamu punya force pun tinggi. So that's why kalau kamu pergi memancing kan, this is you are fishing on the laut fishing dekat laut. So you have this fishing rod This is a fishing rod. Fishing rod. This is you. So happy. This is a, so this over here is the hook, and then you already caught this fish. So you caught this fish. So when you are trying to pull away to capture your fish, you're going to wind your, what do you call here, tackle. You're going to wind it slowly, slowly, and slowly, right? Slowly, slowly, slowly. You will never, you don't jerk it. You do not jerk it. Why? If you jerk it, you might break the wire. So that's why. So when you learn dynamics, you are actually learning about real life lah. You are applying all the physics in real life. So that's why it is important to understand all the concepts in dynamics. So you don't jerk it, you pull it slowly, slowly, slowly at constant velocity. So if you pull at constant velocity, it's basically no force, because your A is equal to 0. Really, no force. If you are pulling at a constant velocity, summation of forces is equal to MA. A stands for V2 minus V1 over time. So M V2 minus V1 or V minus V0 over time. F. Ada juga lah. Ada juga. You can play with velocity also. Okay, so the thing is lower lah. Lower as possible. As low acceleration as possible. In order for you to not have very high force that will break the line. Okay? Penuh dah. Where were we? Macam mana nak cancel semua ni? Delete. Erase all ink on slide. Eraser. Ini clear. Okay, let's take a look at it again. 3,000 kilo. Okay. It's given an acceleration. So acceleration dia berapa? Upward velocity 200 mm per second, 0.3 seconds. So you can use this formula. V is equal to V0 plus AT. If you don't like this formula, V minus V0 over time is equal to A. What are we looking at? Ini adalah final. Ini adalah original. Okay. Final velocity berapa? 200 mm per second. 200 mm per second berapa meter per second? Senang je lah. 0.2 meter per second. Original velocity adalah ni, at rest. Original velocity at rest, so 0 lah. Time 0.3. So this is the acceleration. 0.2 divide by 0.3. 0.2 bahagi 0.3. 0.2 divide by 0.3. 0.67 meter per second every second, right? Or meter per second squared. This is the acceleration. Acceleration equals 0.67 meter per second squared. Determine the tension in the cables. Tension in the cables. So the cable is like this. Apparently the cable is symmetrical lah. So tension kita dalam put is as T lah, tension. So this is 3000 kilo. 3000 kilo is going down lah. mg. Macam tu lah. So if you draw properly, ini kita punya objek kan. mg turun bawah. This one. This one. Like that lah. So this force is T. This force is T. Ini berapa? This angle berapa? This angle berapa? Cuba tengok kat sini. Ini berapa? What is this angle? Answer me. Virtually 60 So ini 60, ini pun 60 lah. Okay. Have you solved this one? Obviously, it is at an angle, so you need to resolve. Resolve into two components. Ini akan jadi apa? T sin 60. Yeah, correct. T sin 60. Okay, this one. It doesn't look good, Draw again. Bigger. This is our block. I'm gonna draw a big one. This is our mg equals times 9.81. Our force is like that. The other force is like that. This is T, this is T. Angles. This angle is actually 60 degrees. 60 degrees. So this portion is actually T sine 30 degrees. Yeah, T sine 30 kah? Betul lah. Not 30 right? 60 right? 60 degrees. 60 degrees. This portion is useless, Useless. T cos 60 degrees. This one. T cos 60 degrees. Useless. Effective dia ini je lah. So, where is the direction of this object moving? Dia naik atas. Upward. So, dia naik atas. A naik atas. So, A lah sini positif. Positif naik atas. So, let's write it down lah. A is actually AY lah. AY. So, summation FY MAY. AY is no longer 0, right? You have acceleration. So, write the answer? What does the equation of motion? So what are we doing? You are writing down right now equation of motion. So no matter which engineering field you are in, mechanical, electrical, mechatronics, manufacturing, design, yeah, you need to know lah equation of motion. Everything deals with motion. So summation FY, ada ni lah kan? Ada T sin 60 naik atas, T sin 60 naik atas, mg turun bawah. Habis. When you write it down, it's gonna be T sin 60 plus T sin 60 minus mg is equal to m/ay. So might as well write down 2t sin 60 berapa? Sin 60 0.866. Tolak 3000 sama dengan M AY berapa tadi? 0.67. M ni kan 3000. You gotta write down 3000 lah. So 2T kali 2. So this one becomes 1.732T tolak kali 9.81 29430 29430. This one equals 3000 kali 0.67 berapa? 0.67. Banyak betul lah. Tolak balik ya. 3000 kali 0.67. 2010 campur 294 30. Ini apa? 1.732T. Okay, so let's observe a bit. It's really rare that you can observe things. Ini apa dia? This comes from mg. Ini apa dia? This comes from MA. So this is the inertia part of it. Berat dia 29430. Yes. Since this block is jerk ataupun accelerated lah, dia ada additional 2000 Newton lah. Ya. Remember? F sama dengan MA. So M kali A sama dengan Newton lah. Newton. Dia ada additional 2000 Newton sebab dia jerking. Accelerated 0.67. Kalau acceleration ni kurang 0.1 ke? Kurang lah ni. This value will become lower. So there is a safe acceleration punya value when you do things engineering. Cranes ke apa, dia tak boleh jerking too hard. If you jerk too hard, cable akan putus. So very dangerous because of this inertia. Okay, so now settle berapa? T sama dengan 29430 plus 2010 bahagi 1.732 18152 engineering 18.2 18152 Newton or 18.2 kilonewton. So apparently tension dekat kabel sama dengan, betul nasib baik 18.2 kilonewton. So 18.2 lah. So katalah ini kamu punya design kan. Let's say you design something like this to move at this much. So you as an engineer, you cannot immediately tell them to run at, actually you can lah, tell them to, okay, so this cable can withstand 18.2 kilonewton. So you have to apply some thing called safety factor. You gotta put some safety factor lah, probably additional 20%. So becomes 1.2 lah kamu punya safety factor. So when you buy the cables, janganlah beli kabel yang tahan 18.2 kilonewton. Buy stronger cables. So tambah lagi lah berapa percentage. 18.2 plus 20%. 0.2 kali 18.2 campur 18.2. Maybe you buy like 21.84 kilonewton kah, kabel yang tahan. So you don't always choose accordingly lah. We engineers have to make things safely. So safety factor is key. Safety factor is very important. Alright, so habis cerita. Where are we now? So sebaik betul. So okay. Okay, we're gonna probably have a break for a while.